This problem is interesting because we have two cylinders. One is rotating vertically and the other is rotating horizontally. We're told that there is a tension here that keeps the slider from moving outwards uncontrolled. And we're told that it is not resting on the bottom, and there is a force of F-theta that keeps it from doing that. And we are to find the force of this tension and the force of that F-theta. In this free body diagram, we're going to be looking at it from the top down. Previously, we've looked at it from the side, but here we need to look at it from the top down so that we can include this F-theta, and this is R here. And R and theta, those axes, are dynamic. As the particle moves, you have R this way and theta this way. And that's why in this case, the R hat and theta hat are so helpful, is because they move along with the particle. Let's solve f of r first. So f of r equals m-a-r. And we're given the equation for AR in the text, so we'll use that to solve our problem. The only force is negative t, so we know that it has to be dynamic because there's no counteracting force, equals m times r double dot minus r theta dot squared. We're given all kinds of information about the motion, so we can plug in and solve for t directly. And that is negative 0.2 times 4 minus 0.8 times 4 squared. Simplifying that, we find that the tension equals 1.76 newtons. So we've already solved for that first force here. Moving on to theta, we get that F of theta equals m times a of theta. And once again, we'll use the equations from the book for a of theta. The only force in that direction is F of theta, and so we know that it is not dynamic because we can't assume that it is zero. And that equals m times r theta double dot plus 2 r dot times theta dot. And once again, we're given all kinds of information about the motion, so we can solve for this directly. And that is equal to 0.2 times 0.8 minus 2 plus 2 minus 2 times 4. And the values of theta double dot and r dot are both negative, where theta dot is positive. And for that reason, we don't know which side f of theta is on. So we're going to assume that it's positive, and later we can decide if the value comes out as negative, if it's actually attached to the other side. And when we simplify it down, we do find out that the value is negative. And for that reason, that cylinder, the force is actually acting on this side. So this would be the positive 3.52 newtons. And there we've solved for both of the forces.